And welcome to Cambridge Chemistry channel with Sarvatyanna. Today I will discuss chemistry paper 9701 variant 22 May June 2024. Let's start. Complete table 1.1 using relevant information from the periodic table. This is nucleon number 24, magnesium proton number. We know from the periodic table the proton number, this is nucleon number, and proton number is 12. So because from the periodic table we know that this is 12 and 24. It means 24 is the nucleon number, which is number of proton plus number of neutron. So proton number is 12. Now this is iron, magnesium ion, and positive. If magnesium carrying 2 plus charge, it means magnesium tend to lose 2 electron. So if magnesium has 12 electron, 12 electron and 2 electrons lost by magnesium, so carrying how many electrons are left behind? 10 electron. So 10 electron over here. And aluminium 3, aluminium also, the symbol of aluminium is this 1327. 13 is the proton number, which is equal to the electron number. So if aluminium carrying 3 plus, it means it minus 3 electron, which is equal to 10 electrons, right? So 10 electron over here, and proton number is 13. State and explain the difference in the ionic radius of aluminium 3 plus and compared to the magnesium. Aluminium cationic radius of ionic radius of aluminium 3 is smaller than magnesium 2 positive. You know that the uh, ionic radius is going to decrease from sodium to aluminium. Sodium to aluminium. So it is aluminium has greater nuclear charge attraction. The reason is this, as because aluminium ion has greater nuclear attraction due to more nuclear charge with same uh, nuclear attraction for remaining electrons, for remaining electrons with same shielding effect. Because aluminum and magnesium are present in same period, so shielding effect, so number of shells remain the same, but nuclear charge is going to increase. So that's why in aluminum has greater nuclear attraction for remaining electron with same shielding effect. So that's why the size of aluminum ion is smaller, radius of aluminum ion is smaller than magnesium. Draw a label diagram to show the structure and bonding in sodium. This is how to draw the metallic bond of sodium. Electrons are delocalized in sodium. Here is the electron. This is positively charged ion, and this is delocalized valence shell electron. You know, metallic bond is the electrostatic force of attraction between positively charged ion and delocalized valence shell electron. D part is figure 1.1 shows the variation in metallic bond but melting point of some period 3 elements in their standard state at room temperature and pressure. Uh, this is the melting point of sodium of period 3 elements. Sodium has lower melting point than magnesium. Magnesium and aluminum has almost same, and again silicon. Silicon, this is aluminum, this is magnesium, and this is sodium. So silicon is higher as it is giant macromolecule. Okay, the question is explain why silicon has a high melting point. Silicon is giant macromolecule, giant covalent structure with strong giant covalent structure, hence large amount of energy is required to break the silicon. Let us complete figure 1.1 to show the variation in the melting points of element P, S and chlorine. So this is P, this is P, this is P, and this is S, and this is chlorine. Why it is so? Because P4 and S8, and this is S8. So you know that the melting point physical properties depends on the number of electrons, and this is Cl2. So it has 15 into 4 electrons, and sulfur has 16 into 8 electrons, and chlorine has 2 into 17 electrons. So over here 60, and 128, 8 6 are 48, and this is 34 electrons. So sulfur has more electrons, so that's why its melting point higher than phosphorus, and chlorine is lower because chlorine has only 34 electrons. Complete 1.1 to show the variation in the melting points of elements phosphorus, sulfur and chlorine. Two period 3 elements react with an excess of oxygen at room pressure Complete table 1.2. Sodium, period 3 element sodium sulfur, state of oxides at room temperature and pressure. Sodium oxide is exists in solid state because it metal. So this is solid, and sulfur form sulfur dioxide, which is gas at RTP, gas. And the pH, approximately pH is 10 to 14, and its pH is 0 to 4. The solution made in column 3 of the table 1.2 are mixed together. 1.2 are mixed together. Name the type of reaction that occur. Column 3 table 1.2 are mixed. So this is sulfur dioxide, this is sodium oxide. So when it is formed, Na2 mixed together, Na2O plus sulfur dioxide. So this is Na2SO3. This is acidic oxide, and this is basic oxide. So when these two oxides react with each other to form salt, so this reaction is, the type of this reaction is acid base reaction. Write an equation to describe the reaction between phosphorus P4O10 phosphorus oxide and an excess of water. So this is the P4O10 plus water to form phosphoric acid. So 4P, and then look at the other 4 3s are 12. So 12 hydrogen atom, place 6 over here. So this is the balanced chemical equation. Aluminum hydroxide is amphoteric. Explain what is meant by amphoteric. Amphoteric mean amphoteric oxides are oxide which react with both acids and bases. React with both acids and bases. Write an equation to describe the reaction that occurs when aluminum hydroxide react with sodium hydroxide. NOH thrice plus sodium hydroxide to form NaAlOH4. So this is all about of this question. Hopefully you would understand. So question number 2 is separate samples of sodium carbonate and sodium hydrogen carbonate react with HCl to produce the same products as shown in table 2.1. This is H1, delta H1, and this is delta H2 plus 27.2. So complete the reaction pathway diagram in figure 2.1 for the reaction 2. For the reaction 2, label the diagram to show the enthalpy changes delta H2 and the activation energy EA. So this is because this is this is an endothermic reaction, so we draw like this. This is enthalpy change, and this is activation energy. And to form NaCl plus water plus CO2. The value of for delta H1 is determined by experiment using the following method. 50 centimeter cube of 2 mole per dm cube HCl is added to polystyrene cup. The initial temperature of the acid is recorded at 19.6 degree centigrade. 0.0400 mole of sodium carbonate is added and the mixture is stirred. All the solid sodium carbonate disappears and a colorless solution is produced. The maximum temperature recorded during the reaction is 26.2 degree centigrade. Describe one other observation that shows the reaction is complete. So in this reaction carbon dioxide is produced. So when no more bubbles can be seen, then the reaction is complete. No more bubbles of gas. So it shows that reaction is going to complete. Calculate the value for value of delta H1 in kilojoule per mole. Assume the specific heat capacity of reaction mixture is the same as for water and show your work, and no heat is lost to the surrounding. Show your working. So the formula, which is because this is how to calculate the heat released. So this is the polystyrene cup thermometer. So this is, first we have we add HCl, then plus sodium carbonate. So we can calculate by using Q is equal to mc delta T, where temperature is initial temperature is 19.6 and final temperature is 26.2 degrees centigrade. So delta T is equal to Tf minus Ti, initial minus 26.2 minus 19.6. So this is delta T. Specific heat capacity is 4.18 and mass of solution is 50 centimeter cube, because volume is equal to the mass. So Q is equal to mc delta T. So by putting the value of M is 450, specific heat capacity is 4.18 and delta T is 26.2 minus 19.6. The value is 1379 joule, because unit of Q is joule. So we have delta H is equal to, and 13 because delta H, the enthalpy change of reaction is enthalpy, unit of enthalpy change is kilojoule per mole. So first, before putting this value into, delta H is equal to minus Q divided by N. So joule divided by 1000 is equal to 1.3794 kilojoule. Now delta H is equal to Q over N. So we have Q, this is delta H1, 1.3794 divided, we have moles. By calculating mole of HCl 0.0400 sodium carbonate mole. Zero point zero four mole. The answer is minus 34.5 kilojoule. Thermal decomposition occurs when sodium hydrogen carbonate is heated. Reaction this is reaction 3. Calculate enthalpy change for the reaction 3 delta HR using the data in table 2.1 and the value of delta H1 calculated in B2. Okay, if you were unable to calculate the value of delta H1 in B2, assume the enthalpy change is minus 38.4. So by using the calculate the enthalpy change of reaction 3, so this is delta HR we have to calculate. So write down equation over here to NaHCl3 to form delta AHR. We have to find out sodium carbonate plus water plus carbon dioxide. So write down the elements over here, compound from which it made. This is the NaCl H2O plus carbon dioxide. This is delta H2. So write down the compounds over here which are formed from the both reaction by reacting with HCl. NaCl plus water plus carbon dioxide, 2 moles and 2 CO2 to NaCl. So make 3 boxes. .2 is the delta H2. Here sodium hydrogen carbonate to form and also formed by reacting with HCl. So this is 27.2 into 2 and delta H are unknown, and this is we have calculated in this value delta H1 34.5. So draw, this is the starting point and this is ending. So draw an arrow. So it is equal to delta HR plus minus 27.2 into 2, no sorry, 34 point, this is using this value delta HR plus minus 34.5 is equal to 27.2 into 2. Another arrow is like this, and by calculating this equation we get delta HR is equal to minus delta HR is equal to 88.9. So the delta HR is 88.9. Z is a salt that contains a period 4 elements from group 2. When Z is heated, brown gas forms. Identify the formula of Z and use it to write an equation. This is heated brown gas, so it means it is nitrate. So calcium nitrate to form, decompose to form calcium oxide plus brown colored gas nitrogen dioxide and plus oxygen gas. So this is H2 gas, oxygen gas, sorry, 1, and this is nitrogen dioxide is also gas. This is solid and this is solid. Period 4 from group 2. Calcium is period 4 and group 2 Question number 3. Describe what is meant by dynamic equilibrium. Dynamic equilibrium is the stage in reversible reaction in which rate of forward reaction is equal to rate of backward reaction and no change in measurable concentration. Reaction 4 describes the reversible reaction between yellow iron and colorless SCN to produce red. This is the product formed. These are the two reactant and this is product. An equilibrium mixture contains iron 3 and sulfur cyanide and uh, ferrosulfur cyanide ion. A few colorless crystals of soluble compound KSCN are added. The mixture is then left until it reaches equilibrium. The temperature of both equilibrium mixture is the same. Reduce the change that color, if any, in the equilibrium mixture after KSCN is added compared to the original equilibrium mixture. Oh, this is if KSCN added. This is, and if concentration of KSCN is increased, the reaction will shift forward according to the Le Chatelier principle, and change in color is red. This will become red, and change in relative concentration of iron 3. So iron 3, because reaction equilibrium will shift forward, so the concentration of iron 3 is lower. Change in value of the equilibrium constant Kc, no change because Kc is only temperature dependent. So there is no change in Kc if concentration of any reactant or product is changed. Part 2, the expression for the equilibrium constant Kc for the reaction E4 is shown. This is the Kc expression. The 5.00 into 10 raised to minus 5 moles of this reactant and mole of SCN are added together and allowed to reach equilibrium. The total volume of the mixture is 25 centimeter cube. At equilibrium, the concentration of this product is 4.23 into 10 raised to minus 4 mole per dm cube. Calculate the equilibrium constant Kc for the reaction. So this is the expression. Iron 3 plus SCN negative to form product CN2 plus. So this is the product, and we know that this is 5 into 10 raised to minus So first calculate the concentration of iron and SCN, like 5 mole over volume into 10 raised to minus 5 divided by 25. So it is equal to 0.002 mole. So because 1:1 ratio, the same concentration of SCN ion. So initial concentration is 0.002, 0.002, and the over here 0. So in question, equilibrium concentration of product is 4.23 into 10 raised to minus 4. So reactants left behind, if this is formed, the reactant left behind is 0.00423 and 1:1 ratio. So this is also 0.00423. This is change more. And if we subtract 0.02 and the at equilibrium, the concentration would be 0.001577, or this is also 0.001577. So write down the Kc expression, put the values in Kc expression. 0.00043 into divided by 0.001577 square. So the answer is 170. So this is 170. The unit is mole dm inverse cube mole cancelled out, and we have unit mole minus 1 dm cube. Determine the full electronic configuration of iron 3 plus. This is 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. And over here, and this is because cyanide ion is like this. So this whole pair is donated to the sulfur. This is from any other atom, carbon gains electron, so that's why it's carrying negative charge. So this is formed a bond with sulfur.